Hey everybody, this is Alex Merced from alexmercedcoder.com. Been a while a few days since I made a video, mainly because I've just been kind of focusing on like learning Scala and practicing Scala and things like that. But I was watching one lecture on Scala that I thought was very interesting, and I actually saw a few videos on sort of like database indexing and whatnot. And I'll be doing an episode on the Web Dev 101 podcast about data and explaining a lot of these data concepts. So I highly recommend subscribing to that if you don't already. But and basically what I'll do is just talk about like functional programming and some of the techniques of functional programming that you could use. Like this talk was focusing on implementing these things in Scala, but I was like, this could work just fine in JavaScript, and it's really cool. This is kind of like just being able to think through like how do I use functional programming to my advantage, and how could you actually mix it with object-oriented programming? Like, how could I combine these different tool sets that I have of how to think and solve problems into pretty awesome solutions? So generally the idea when you're like thinking about functional programming over like object-oriented programming is the idea is you want to do something called function composition, which means you're basically, if I were to think about my program, what needs to be done in a particular process. So if I were to overall, so let's say overarching, let's do this in a comment. If I'm thinking about like a web process, and that was the example I used in the lecture, and I thought it was like a really good example, is that basically all a web process is like you're handling a web request. A web request equals a function. Okay, and again, every function takes in some data and returns something else. So what does a web request takes in? It takes in a request. Okay, and it returns a response. So essentially, as long as you can create a chain of functions that starts with a request and ends with a response, you could, basically break this process down to functions. So imagine thinking, okay, well, if that's the case, if my web request, and again, if you've used Express, you know what I mean. You have that rec object, that request object that comes in. Okay, you can imagine that I first create a function that takes the request and returns, okay, let's say we're making it an app for creating new events, okay? So we'll say it returns the event data. Okay. Then we have another function that takes in the event data. And this is like the data that's going to like add it to the database. So it'll commit to the database and then grab the database from the data. So then it'll return like the event record. Okay, so basically this function takes in the request, returns the data that's going to be used to commit to the database. This function receives that data, and then again, let's give each function a name. Okay, we'll call it like get data, and then we'll have add to database, and then we want to take that event record and we want to return it as JSON. So we'll call this send response. Okay, and then that would equal, that would receive the event record and then send return a response. So technically right here, we've broken up this process, this web request process, into 3 functions. But see, at the end of the day, it starts with receiving the request and receives the response. So basically, at the end of the day, you end up with this. Okay, I'm going to send a response, and the response is going to be the result of add to DB, who's going to use the response of get data, and get data receives the request. Okay, and then technically right there, that's your whole processing of the web request. Okay, and ideally, again, you in functional programming, you want everything to kind of be sort of one argument. It's like one thing goes in, one thing comes out. So this is where like curring gets involved. So So then what happens is that, okay, well, here we're going to need the database connection. Okay, so I need the database connection to exist. Okay, I could make it say, hey, here we need this and database connection, but that gets kind of in the way of that nice flow of that we had there at the end. So actually, like being able to have this. Okay, it's going to kind of get in the way of that nice sort of pretty response. And then again, this is pretty semantic, right? I can see be like, okay, I'm going to send a response after I add to the DB and after I get the data, which is coming from the request. And that's the nice thing about like functional programming. Like if you do it right and you set up your functions right, the end result is pretty reasonable. So I can say, hey, we're starting with the request. I'm going to get the data, then I'm going to add it to the database, and then I'm going to go send the response. Okay, all in one line. How nice is that? Okay, and it's very semantic and very readable. And it's really easy to understand, so to understand the sort of the flow of events and what each function is doing. And at the end of the day, each function is separate. Like this function isn't dependent on this function. Okay, all that matters is that it gets some sort of event data. So in some other context where I want to add event data that I might have gotten from somewhere else to the database, I can use that same function. Okay, same thing with send response. Like they're not dependent on each other. So I've created these independent functions that I can compose into sort of what I need to get done, because they all represent a step, but that step could be part of multiple processes. And that's sort of like the nicety of like functional programming and thinking everything as what goes in and what needs to. So this step, what I need to start this step, and what needs to be come out at the other end of this step. And then I can create all these things where I can compose these functions together. This is referred to as function composition. But again, I might have that situation where I need two things, like the database connection. So how can I handle that? This is where like having a class can come in, okay? So I could do something like this. So I would write a class. I will say like, let's say class called handle request or request handler. And then I'll use the constructor to receive that one thing. Constructor, which will receive the DB connection. Okay. I will just say DB connection or this dot DB connection equals this dot DB connection. Okay, and then again we would define these methods, these functions. Okay, so I would, we would sit there and have like get data, and again get data receives the request. Okay, and then we'd have the whatever code here. We'd have add to TB, which would take in the event data, which we'd have that code there, and then we would have send response, which would receive the event record, and then we'd have the code in there. Okay, and then technically here I can instantiate a class, and I could even make this like a static kind of thing. So so what I could do is I could no, that'd be fine. So basically what I would do is I would then say const rh equals new request handler, and then I would pass it the DB connection, and now I could just do rh dot send response, rh dot add to DB, rh dot get data, and again that would pass in the request, and we're back where we started. Okay, and so that basically each function could still just handle one step of the process, but then if something that I'm going to universally need, like this is not something that I'm going to need for every, like I want to have one database connection, and that's going to be handled anytime I have this request response cycle. So that's a good thing to kind of have available just sort of on out. So that becomes a good use of a class, because hey, this is just something I'm going to need every single time, and then again I can handle the different data that comes in here. Okay, so the request data is going to be different. So these things may generate different output because I'm going to give them different input. But the one thing that's really never going to change is the database connection. So in that case, that can just be a property of a class, and then I just do the function composition from within the class. But I'm still kind of handling it from that sort of one thing out, one thing out. Notice I'm not mutating any properties of the class, so I'm still avoiding sort of that object-oriented programming paradigm of saying, hey, I have this thing that's constantly changing. Instead, I'm just using the class as a container to hold sort of arguments that never change. Okay, to keep things simpler, so that way I can keep my composition, my function composition, nice and pretty like this. Okay, so hopefully that gets you thinking about how to write your how to write and plan your function. So notice I didn't actually implement any functions here. I didn't actually like write what this function does, but by planning ahead, by saying, okay, this is what's going to come in and this is what's going to come out, I already have like a thought process of what each function should do. And long as I stick to that plan, like long as this function takes in this request and returns the right thing, and these three functions return the right thing, I'm going to be able to use them together just like that. And again, that becomes easy to read because I know when I'm going to receive the request, at which point I'm going to get the data, then add it to the DB, and then send the response. Okay. So yeah. That's so again, data in, data out. There's also things like function currying, which allows you to kind of break this up. So if you had that second argument, you could have that database connection. You could use currying as a way to inject it, and still kind of maintain this. Okay, like how would that look like? So if I were to do this without the class, just to show you how like this would look like with function currying. Okay, we would have had like const. We would have had const get data, which would equal again takes in the request and returns the event data. Then I would have const add to DB. Add to DB. We'll just say add to DB. Yeah, just leave it at that. Which would take in the database connection and then return a function that takes in the event data, which then returns the event record. So notice I chopped, instead of having one function that takes in the database connection and event data, I said, okay, hey, let me just have a function that takes the database connection initially, and then I'll get back my real add to DB function. And then we'll say const, and then we would say const get response or send response, which would take the event record and then return the response. Okay. So the difference is the way this would work, and again, this is not like this code won't run. This is not there would actually have to be some sort of implementation here. I'm not implementing these functions, so this is all sort of high level. Okay, so keep in mind like this would actually probably be a bunch of code, or maybe even just one single expression that results in a response, that results in an event record, and so insert code there. But so now the way the code would look like, it would be like const, okay, new add to DB. And what would happen is I would take add to DB, pass it the database connection, and now I have a version of add to DB that will always have the database connection. Because again, basically I take in the database connection and get a function that now will use that database connection going forward. And now again, I end up back in the same spot. So I could be like send response from using the result of new add to database, which is going to use the result of get data, which will use the request. Okay, so that's like the benefit of like function currying. So that way I don't have to pass the DB connection every time I use add to DB. I can just pass the connection one time, and then I get returned a function that already has the DB connection nested in there, and I can just reuse that function instead. So instead of always saying, okay, hey, these are all the things I need, and having 2 or 3 arguments to the function, I can say, okay, well, the first thing I do need, but it may not really change. So let me just get that first and just return you the function with that already baked in. And then, you can go so forth and so forth. And now I can still have this sort of nice function composition because I connected the database connection over here. Okay, so that's what's called currying. And then again, another sort of like functional technique you could use to further optimize is you could use memoization, which I'm not going to show. I have a separate video on memoization where that's where you cache the results of the function. Again, this is what you would do this for like functions where you're doing like expensive calculations. So you're doing a long calculation that's always going to end up being the same result with the same input. So what you do is you add to the function a step that checks, okay, have I done this calculation before? Let me save that result in an object, and then I'll check to see, hey, do I have this result already in the object? Because if I already have it, I can just use that instead of recalculating the whole thing, and I can give you the result real fast. Okay, so memoizing functions that do expensive calculations can be a real, but that's only doable if the function's pure. So basically the idea is that if you don't mutate anything from the outside, like if the only data from the outside the function that's used in the function is what's passed in as an argument, then you can memoize. That's why it's important to write functions in a particular way in functional programming, because if you don't avoid side effects, meaning your function internally affecting things outside the function, or using data from outside the function. So if you avoid all that, you keep your functions pure, which means, things go in and things come out. And that's basically any data that comes in from the outside has to go in as an argument. And the only data that comes out as the return value. Then you can use things like memoization and currying and use them to really, like currying and function composition, make your code just a lot more readable and a lot more sensical, and you can really result you in writing a lot less code. And then things like memoization can actually improve the speed of your code. But you have to be disciplined about how you write your functions, which just means taking a moment to plan sort of what your functions take in as an argument and what they return as a value. So hopefully you found that of value. But again, you can splash in a little bit of object-oriented programming by taking advantage. So in places where maybe currying may not necessarily, you could use currying, but maybe you want to use not currying, you can do something like this where you can take advantage of class constructors as a way to pass in sort of data that might be to keep your function sort of one argument, one return value functions. So that way you can really kind of have nicely composed statements like this that are kind of easy to read. Okay, and easy to kind of think through, and that's the benefit of like functional programming. My name is Alex Merced from alexmercedcoder.com. Have a great day and enjoy.